So a lot of the questions in this unit, since you're working with radians for the first time, you're going to start by just seeing, can you convert from one thing to the other? Can you change from radians to degrees, from degrees to radians? So in part A, you've got 170 degrees. You want to change it to radians. It says write it as an exact measure. So whenever we do exact measures, we'll leave our answer with pi. And whenever we do an approximate measure, that's when we type everything into our calculator and figure out what it's equal to. So 170 degrees, well, if you remember that 1 degree is equal to pi over 180, then 170 degrees will just be 170 times by pi over 180. This is 170 over 1, so when we put this together as a fraction, multiply the tops, multiply the bottoms, you could leave this as 170 pi over 180. On the final exam, they will accept this. They will also accept if you wanted to simplify it. That would be fine as well. 17 pi over 18. That's an exact measure because you haven't done any rounding. Now if we type in 17 pi over 18, to the nearest hundredth, we'll get 2.97. So that would be rounding to the nearest hundredth, and that would be an approximate value. Now if I asked you to sketch 170 degrees, you'd be pretty good at that, right? Visualizing 2.97 radians won't happen for a while. Okay? So sketching 170 degrees. Here's my circle. Does that look like it about 170 degrees? Yes. How do we sketch radians? So let's say I didn't have the 170. I was just told 2.97 radians. How would I imagine that going around a circle? Well, one of the things that's helpful, so you remember, well, how much is a whole circle? All the way around is 2 pi, 6.28. Halfway around is pi, 3.14. So if you think of this as 3.14, half of that would be 1.57, and you were asked to estimate 2.97, you might come up with the same angle as 170. But for now, our minds are, we've been dealing with degrees for a long time, right? You never buy a compass set and get a protractor that's in radians. Your protractor's in degrees. So you have a visual of what a degree looks like from a long time. And now we're trying to develop that same thing with a new measurement. So in part B, we want to sketch negative 12 pi over 11 radians. Well, just like degrees, a negative angle, all angles in standard position start here. A negative angle will go around in this direction. So we need to figure out where will negative 12 pi over 11 be. Well, we know that halfway around is pi, and all the way around is 2 pi. So starting at 0, but all the way around would be 2 pi. Can you see that 12 over 11 as a fraction is a little bit more than 1? So if we have 12 over 11 pi, we need to go a little bit more than 1 pi. So as far as our angle is going to go, we're going to start here. We're going to go a little bit more than 1 pi. That's the starting estimate. If we changed negative 12 over 11 to a mixed fraction, that would be negative 1 and 1/11. If you split up, if this is 1 pi and you split it up into 11 little sections, we need to go 1 and 1/11 more. That also tells us that that last little bit should be fairly small. But there we have an estimate of drawing negative 12 pi over 11. We want to find out what that is in degrees. Well, so how many radians? We found out that 1 radian was 180 over pi. So if we want to find out how much negative 12 pi over 11 radians is, we would have to multiply by 180 over pi. Notice your pi's will cancel out here. And if we type this into our calculator, negative 12 times 180 divided by 11. We get approximately, calculators, 196.4. Which seems to match up with the picture that we drew, just a little bit more than 180 degrees. And then in part C, given theta is 7.5 radians, change that to degrees. Oh, I want to point out one thing before we go to C. A shortcut that some people use for changing radians to degrees. So what do we do here? So far, we're multiplying by 180 over pi. A shortcut is whenever you have pi in the radians, when you multiply by 180 divide by pi, can you see that the pi's are going to cancel out? So whenever we have pi in the equation, a shortcut that people use is they just replace the pi with 180. And that'll give you the same answer every time. Partly because the pi's cancel out, and also because pi radians is equal to 180 degrees. So if you change that right away, then you'll get the right answer. So finally in part C, we've got 7.5 radians. You want to change that to degrees. 1 radian is 180 over pi. So when we multiply this out to the nearest tenth of the degree, we get 429.7 degrees. All right, I'm going to give you some time to try a couple of these. 4, 5, and 7.